Good morning everyone. My name is Akshara Singh Chauhan. My roll number is 22 and the topic of my presentation is motion of rocket. To understand motion of rocket, we'll have to understand what is a rocket. Rocket is an engine that produces a force, that is a thrust, by creating a high velocity output without using any of the constituents of the atmosphere in which the rocket is operating. That means that it can operate in any part of the atmosphere, either inside or outside, which makes it ideal for space propulsion. The thrust is produced because the rocket engine must have exerted a force on exhaust material, and an equal and opposite force, that is called the thrust, therefore exerts on the rocket. Now there are types of rockets present: a chemical rocket and a non-chemical or solid rocket. The only difference between them is that in the combustion chamber, for example, in the combustion chamber of a chemical rocket, a liquid propellant is present that produces the gas jet, whereas in a solid or a non-chemical rocket, inside the combustion chamber, a solid or a gaseous propellant is present that produces the gas jet. Now talking about the motion of a rocket. Rocket motion is based on Newton's third law and the principle of momentum, which states that for every action there is an equal and opposite reaction. It consists of a combustion chamber in which liquid or solid fuel is burned. The heat of combustion raises the pressure very high inside the chamber, so the hot gases are expelled from the tail or the nozzle of the rocket. Here you can see that just below the combustion chamber there is the tail or the nozzle that produces the gas jet. Gas jet with a very high exhaust velocity, and the rocket moves in the forward direction. The reaction force acting on the opposite direction is called the thrust force. The thrust force just causes the rocket acceleration. These are the internal forces in the rocket gas system. In the absence of external forces, the total momentum of the system is constant. So the gas jet acquires the momentum in the backward direction and rocket gets equal momentum in the forward direction. Here we can see that the gas jet produces the thrust force, and the reaction force because of the thrust makes the rocket moves in the upward direction. Now it is also an example of the system of variable mass. As time goes on, the mass of the rocket, which includes the mass of the remaining fuel, continuously decreases. Thus, even though the force of the rocket is constant, the resulting acceleration goes on increasing. Now moving on to the rocket equation. So to derive the rocket equation, let m be the total mass, that is the rocket plus the fuel, at time t, and v be its velocity. Let a mass dm be ejected from the rocket in time interval dt in the form of gas jet. And if u is the velocity of the gas jet being ejected, then its relative velocity with respect to the rocket would be vr, where u is the velocity of the gas jet and v is the velocity of the rocket. Now here velocity vr is the exhaust velocity. Now by the Newton's second law of motion, we have m into dv upon dt is equals to fe plus vr dm upon dt. Now from the second law of Newton, we know that F is equals to ma. M is the capital M, that is the mass. A is the acceleration, written like this. And the total force is written as Fe plus Vr dm upon dt, where Fe is the external forces that consist of gravitational force and the drag force, that is the resisting force acting upon the system. And Vr dm upon dt is the force of reaction exerted on the system by leaving mass, that is the thrust force. So now if we neglect the drag or air resistance and the change in gravity, then here we can say that Fe is equals to mg. Putting this particular value in the above equation, we'll get m dv upon dt is equals to mg plus vr dm upon dt. If the rocket moves upward, then v is the upward direction, v, r and g are directed downwards, so they will have a negative value. So putting the negative value in the equation, we will get m dv upon dt is equals to minus mg minus vr dm upon dt. Further evaluating this, we can get dv is equals to minus g dt minus vr dm upon m. Integrating the above equation, when the motion starts at time t is equals to 0 with velocity v naught and the total mass, that is the rocket plus fuel, m naught, up to an arbitrary time t, we will get is equals to v naught plus vr log e m naught upon m minus gt by integrating the equation within the particular limits given. Now, if we neglect the value of g in the above equation, we will get v is equals to v naught plus vr log e m naught upon m, where t is the time required to burn all the fuel, m is the final mass, and v is the maximum velocity attained by the rocket. The above derived equation is known as the rocket equation. Thank you very much.